Now that we have looked at standard form, we can actually use standard form to our advantage. Standard form is actually a very helpful form of writing equations because it allows us to find the x and y intercepts of an equation in a very few steps. Most linear equations intercept both the x and y axis, and when they intersect the x and y axis, the point in which the graph intersects the x-axis is called the x-intercept, and its point, it has the x-coordinate of x, whatever its x value is, and then the y-coordinate 0. And the point in which the graph intersects the y-axis is called the y-intercept. And its point is here with the x-coordinate being 0 and the y-coordinate is being whatever the y value is in which it intersects. And if, that doesn't make sense, hopefully it will in a few minutes after we look at some examples. We are going to look at the equation x minus 5y equals negative 15, and we're going to find the x and y intercepts for this equation. And I have some steps here, bullet points really, that will help us find the x and y intercept. To find the x-intercept, we're going to substitute a 0 for the y variable and solve for x. And to find the y-intercept, we're going to substitute a 0 for the x variable and solve for y. Now, why does that work? Well, if we think about the graph, if I can hit the right button, if we think about a graph, and I'm just drawing random line here, and we're going to look at the intersections of this line. And this line intersects the x and y axis. We have the intersection of the y-axis here and the x-axis here. Just a reminder that this is the y-axis and this is our x-axis. The x-axis is horizontal, y-axis is vertical. They intersect at the origin, creating our coordinate plane. If we're looking for the point here at the y-axis intersection, we have to ask ourselves, to get to that point from the origin, how many spaces do I have to move left or right first? Well, it's already on the y-axis, and so I don't move left or right. So my x-coordinate is 0, which is why that original point is 0. And then I would go up however many spaces I need to go to get to this point. So whatever this value is here on the y-axis, it could be a 3, it could be a 5, I don't know, it could be 165, 123, or it could even be negative if the graph had been drawn a different way. But whatever that value is, we'll call it y. It creates our point y, 0, y. And a similar concept here for the x-intercept. From the origin, we can move left or right depending on how our graph is drawn. In this case, we're moving left, and we're going to move left until we get to wherever our x value is. This case, it would be negative 5, negative 10, negative 2/3, whatever it is, we'll call it x. And then from there, we can move up or down to get to the y, which we actually don't need to move. We're already there. So it's just going to be 0. And that is why we have these kind of general forms here of x, 0 for our x-axis or x-intercept, and 0, y for our y-intercepts. So we're going to use that concept to find our intercepts. I put that in that corner there for us to look at and reference as needed. And let's start with finding the x-intercept. To find the x-intercept, we're going to substitute a 0 for the y variable. And once again, that might seem a little backwards, that we're looking for x, but we're substituting for y. And that's once again because if we're looking for the x-intercept, we're looking for x. The y in the point is going to be 0 because we're looking for a value for x. So the x-intercept, this is what we're looking for. In order to get that, we're going to set y equal to 0. So I'm going to take our equation, and where I see y, I replace it with 0. And the good thing about it being in standard form already, this works if it's not in standard form, but the good thing about it being in standard form already is I can do a lot of this mentally. 5 times 0 is 0, and in this case, we're just left with x equals negative 15. Well, now I just write my point. I know that x is negative 15, and we know that y is 0. My point for my x-intercept is negative 15, 0. What about my y-intercept? This time, I'm replacing x with 0. And once again, since this is in standard form, we have this nice little, the zeros cancel here. We have this nice little equation here. It's a one-step equation that we can kind of do in our head because this 0, the x is gone. We're just left with the minus 5y. So I could, in my head, just divide by negative 5, getting that y equals 3. And now I know that 0, x is 0, y is 3. So my y-intercept is 0, 3. Notice once again that my intercepts are points. I know that x is 0 and y is 3, but my answer is not x is 0, y is 3. My intercepts, your x-intercept, is the point in which the graph intercepts the x-axis. It is a point. We need to write our answers as points. So we're going to use this concept to help us graph. So we're going to find the x-axis and the x-intercept and the y-intercept. So I'm putting x equals 0, which means we're going to find the y-intercept first. And the x kind of disappears, leaving us with just 5y equals negative 40. Well, if I divide both sides by 5, I know that 40 divided by 5 is 8. So negative 40 divided by 5 is going to be negative 8. And then I can go and do the same thing for the x-intercept. Five times 0 is 0, so that leaves me with 4x equals negative 40. I can divide both of those by 4, and I know that 40 divided by 4 is 10, so we get negative 10 because negative 40 divided by 4 is negative 10. And now we have 2 points, and these 2 points are both negative values for my x and y. So it looks like we're hanging out over here in quadrant 3. So we're gonna, let's see, we're gonna draw I can get my lines going. There we go. We're going to draw our grid kind of off-centered and put our points. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. One, 2, 3, 4, 5, 6, 7, 8. Not very straight on the points. There we go. It's a little bit better. And let me make sure I put the points in the right place. X is 0 and -8, 2, 4, 6, 8. X is 10, 2, 4, 6, 8, 10. Looks good. And that is graphing with X and Y intercepts.